Hi, my name is Ryan, and over the course of this web series, playlist, whatever, I will be teaching AP Chemistry concepts. I took the class last year, 2021 to 2022. I had an A. I think I did pretty good, and I did take the AP exam. I don't know what I got, but I went in feeling confident, and I went out feeling pretty great. I think I got a 5 or a 4, but I'll let you know when I get my scores back. But I will first be teaching Unit 0, at least that's what my teacher called it, Unit 0 of AP Chemistry, which is stuff that you were required to know before you went into the course. I did not know this stuff going into the course as I came in as a sophomore, and therefore I never took an honors chemistry course. So I had to learn all this over the summer, and many of you might be doing the same. So the first thing that you should learn uh, is unit conversions and units and stoichiometry and dimensional analysis, all that fun stuff. You should learn that first because it's kind of the basis of everything else you're going to be doing. And if you don't learn it first, you'll get really confused, like how I decided to go learn what a what molarity is and like all that weird stuff before learning what a mole is. It just made absolutely no sense to me. So let's start with that. What is a mole? So mole is just a scientific unit to say how much of something you have. So a mole is 6.02 times 10 to the 23rd atoms or compounds or whatever. So let's say that I have 2 moles of hydrogen. Well, if I want to know how many atoms of hydrogen I have, all I would do is multiply this number by 2. And I would get 12.04 times 10 to the 23rd atoms. Now, an important thing to note is that all elements have the same amount of atoms in a mole. That's kind of a misconception. A really, really heavy element has just the same amount of atoms in a mole as hydrogen. So, therefore, a mole of hydrogen is going to weigh a lot less than a really heavy atom, such as astatine, which has a molar mass of 210. So, what is molar mass, first of all? Molar mass, you find at the bottom of your periodic table, like element overview, I guess. I'll paste a picture in a sec. Right there. So, if you look at it, this is boron. Oh crap, that's boron. So boron has a molar mass of 10.81. So the units of that are moles per grams. So this basically means that 6.02 times 10 to the 23rd atoms of boron. Sorry, my handwriting is atrocious. Jesus Christ. Of boron is about 10.81 grams. And that's that. It's as simple as that. Just remember that those are the units of molar mass. And molar mass is also commonly abbreviated as mm, like that. So yeah, those are units. So the last thing about units I'm probably going to go over in this video is metric system units. So this is going to be mainly what you're going to be doing in chem. So you're probably going to recognize most of these. Wrong color. You're probably going to recognize most of these, like a centi and a milli. But you might not recognize a lot of these. Like, I still don't really know what a nano is or a giga, like the specifics of it. Like 10 to the negative second and 10 to the negative third, 10 to the negative sixth. And the symbols, especially the symbols, like the symbols for micro and nano, always trip me out. So it's really important to memorize these. I remember I was tested on these for Unit 0. So just remember these numbers. They're not too difficult. There's some more. I don't think those really matter, especially only in AP Chemistry. Maybe they'll matter more as you go farther into science if you do want to pursue that. So yeah,
Just remember some of these. Okay, so last thing, dimensional analysis. I'm just going to abbreviate it as, oh crap, I'm just going to abbreviate it as DA. Has a really weird name, but it's actually really simple. It's just converting units to get to the units that you want, or you could also say getting your units to agree with each other. So let's use this example. Since Miss Hart loses 3 cats in 1 year, what is her rate of losing cats? So the rate that we want is cats per year. Cats over years. So since Miss Hart loses 3 cats over 1 year, just get your units. And you have 3 cats per year. That's literally stoichiometry. Now it gets a little more complicated with the second example. So you already have your 3 cats per year, right? I'll read the example to you first, sorry. How many grams of cats does Miss Hart lose per day? Assume that each cat is exactly 20 kilograms. So, since we already know the rate, 3 cats. Hello, my handwriting, Jesus Christ. 3 cats per year. So, first I'll convert to days. So, I have to get rid of the years here. So, what I'll do is I'll say year. So, 1 year is 365 days. This might look kind of weird, but I promise you, it makes sense, kind of. So, 1 year over 365 days, these units cancel out. So then you have 3 cats divided by 365 days, right? So now you want to cancel out cats. You want to have grams. So then you'll say 1 cat, so like, yeah, 1 cat is 20 kilograms. So that will cancel out the cats. And then you'll say that 1 kilogram, remember from our previous units, is a kilo. And a kilo is, I believe, 10 to the third, right? Yes, 10 to the third. So then you multiply this whole number by 10 to the third to convert kilograms to grams. So then, so 10 to the 23rd grams is, 10 to the third grams is 1 kilogram. So I'm going to go over all of these before doing calculations. So when you want to convert years to days, you would cross out the year units to get days. And then when you want to get rid of cats to get grams or kilograms, you would say that each cat is 20 kilograms, or 20 kilograms is 1 cat. And then same thing for kilograms. You would say 10 to the third grams is 1 kilogram. 20 kilograms is 1 cat. So then, let me get my calculator. 3 times 20 times 10 to the third divided by 365. So, Ms. Hart loses 164 grams of cat per day. Interesting. So, that is my quote-unquote practical examples. I will be going into actual chemical examples in just a second. Okay, so how many atoms are in 4 moles of carbon? Well, we know that everything has has the same amount of atoms in a mole. So the constant number is 6. We know that it's 6.02 times 10 to the 23rd atoms per mole. As you need 6.02 times 10 to the 23rd atoms per mole. If you want to think about it a different way, you need this many for only one of these, right? So now we need to see how many we'd have if we had 4. So times 4 moles of carbon, and these are all carbon. And then you would do your little calculations, your cute little calculations. Let me do that real quickly. that would be 2.408 times 10 to the 24 atoms. Or you could also say it's 24.08 times 10 to the 23rd atoms. 24, yeah. The reason why is you could also say 2.408 times 10 to the 24 is because that is the scientifically correct way of putting it. But for now, you could just still stick with this. This works too for now. Next problem. Let me just erase all this. Okay. So next problem. How many grams are in 9 moles of carbon? Well, we know that the molar mass of carbon is 12.011. So we can just write that down, 12.011 G per mole, as you need 12.011 grams per mole. So then you multiply this by 9, moles carbon, sorry, specifically moles carbon, 9 moles of carbon. So this is dimensional analysis. This is all there is to it. You're just trying to get these units to agree so that you can get to your desired unit, which is grams. So you're trying to get rid of moles. So how I'm getting rid of moles is by multiplying it by moles. So these cross out, or the moles, not the number. The moles cross out, and then you just multiply. So let me do that. 12.011 times 9. That is going to be 108.09 grams. That's your answer. So that's all. That's units, and that's stoichiometry. I mean, sorry, not stoichiometry. That is dimensional analysis. See you next time, I guess. See you next video. See you in 30 seconds. Bye.